Here we're tackling the problem most profit assigning work, which we want to try and solve with minimum complexities of O n plus m log n time and on space. In the problem statement, we have n jobs and m workers. We're given three arrays: difficulty, profit, and worker. Each of the jobs has a corresponding difficulty and profit level, and each worker has an ability level. A worker can only complete a job with a difficulty level at most equal to their ability level. The goal is to maximize the total profit by assigning jobs to workers. Each worker can be assigned at most one job, and the same job can be completed multiple times by different workers. However, if a worker cannot complete any job, their profit will be $0. And that's something I'm worried about my own ability level in the tech industry. Anyway, we need to determine the maximum profit achievable by assigning the workers to the jobs. You have four possible methods for a solution here. The most optimal is between these: A, dynamic programming; B, union find; C, binary search; or D, sorting plus greedy. I'm going to pause for a couple of seconds while you think about the choice. So, for those of you who are able to get it, congratulations. And for those of you who just want to see the code, the answer here is D, sorting plus greedy. In the brute force approach, we try every possible combination of job assignments and calculate the total profit for each of them. We would then be able to return the maximum profit among all of these combinations. However, the time complexity is pretty terrible. Now, let's take a look at our optimized solution. As you can see, we're using a sorting and greedy approach to maximize the total profit here. We sort the jobs and workers arrays in ascending order. First, making a separate jobs array using this vector of pairs here. And after we've sorted both workers and jobs, we iterate through the workers and assign them jobs starting from the lowest difficulty. However, for each worker, we find the job with the highest profit among the available jobs they can handle, while storing whatever that max profit is somehow. We keep track of the current maximum profit, updating it whenever we find a higher profit job, and also make sure we keep a track of the total profit as we iterate through each worker. So, let's take a look at the line by line just to make sure there's some full understanding here. So first of all, we've got our three vectors coming in: difficulty, profit, and worker. And the first thing we do is create this empty vector jobs, which consists of pairs storing the difficulty and profit values of each job. We iterate over the difficulty and profit vectors using an index I. For each of these indices, we create a pair containing difficulty I and profit I values, pushing it into our jobs vector. After the loop, our jobs vector will contain pairs of difficulty and profit values for each job. We then sort the jobs vector in ascending order using the sort function. After that, this ensures that jobs with lower difficulty are always first. We then sort the worker vector in ascending order, also using that sort function. So, we'll be starting with the least skilled workers when we go through the array. Now, after that, we've got three variables initialized: job, and this keeps track of the current job index from within this array. Current profit or cur profit, which stores the current maximum profit for a job, and total profit, which will accumulate the total profit and will eventually be what we return. We iterate over the worker array using index I, and inside the loop we use this clever while loop. This finds the the highest profit job that the current worker can handle. Our while condition checks if the current job index is less than the size, and also if the worker's ability, which is worker I here, is greater than or equal to the difficulty of the current job, which is job's job.first. The index of the job and then the difficulty, which will be the first of the pair in the jobs vector. So, if the condition is true, it means our worker can handle the current job. We update current profit to be the maximum of current profit and the profit of the current job, which is job.second. After that, we increment the job index to move on to the next job. But note, and again, this has some real-world truth, the difficulty of the job doesn't necessarily mean you'll have a bigger profit, which is why we maximize among the job profit and cur profit, like so. There's no guarantee it's going up every time. Anyway, after we've gone out of this while loop, and once we've found the highest profit job the worker can handle, we add the profit, which is cur profit, to the total profit, like so. We then do this for all workers in the worker array, and once that's done, we return total profit, which should be the maximum profit achievable after assigning workers their jobs. So that's it. I hope that helps, and if you need a more visual representation and a better explanation, I can recommend this course, which is in the description to this video. In any case, we'll have a look one more time at the question and the potential methods to use. And if you've paid attention, you'll know that sorting plus greedy is used to solve most profit assigning work. There's an explanation as to why in our application, although I will have to double check that time complexity is correct. We've given it as O n plus m log n. We also have some code that may help you if you prefer to read through code to understand solutions. We have it in Python and Java, as well as in C++. So that's everything for this problem. We'll be continuing the learning mode of Coding Card Sharp's algorithm pack with reduction operations to make the array elements equal. A long title for a relatively difficult problem.